Good day, dear organizers and participants of the conference. We bring to your attention a report on the topic using Blippar to create augmented reality in chemistry education. Augmented reality technologies create unique opportunities in education. By applying art technologies to the educational environment and by supplementing them with appropriate visual information, it is possible to create a visual model of educational material. This was the reason for the introduction of art technologies in the learning process and practical training of future chemistry and biology teachers and motivated us to create teaching material with art elements and to conduct classes using augmented reality applications. The potential of augmented reality technologies in distance education should be emphasized in particular. Without the possibility of face-to-face communication with the subject of the educational process, the teacher has not only to present new material in video telephony software programs, to provide texts and videos for study, but also to make educational material as accessible and comprehensible as possible, as well as constantly stimulate the interest of students. Augmented reality technologies are quite capable to coping with these tasks. In recent years, more and more attention has been paid to the use of augmented reality technologies in the study of various subjects, including chemistry starting from school. Different applications can be used to create augmented reality objects and elements while teaching chemistry. They vary in complexity, accessibility, and functionality. For example, R Toolkit, HP Reveal, Vuforia, augmented platforms, mobile application entertaining chemistry R, RChemX, RChemi, and others. At the Department of Chemistry and Methods of Teaching Chemistry at Sumy State Pedagogical University, applications for creating augmented reality have not previously been used in the educational process. To find out if the students of the Faculty of Natural Geography at our university are familiar with augmented reality technologies, we conducted a survey of students of different courses and specialities. The planning of the experiment depended on the answers received. After all, if students are not familiar with augmented reality technologies, they need introductory classes, training in the application, and getting used to it. More than 40 respondents replied. We have summarized all the responses received. The analysis of the results showed that only 18 and 6% of the surveyed students of the Faculty of Natural Geography really correctly understood what augmented reality technologies were and used them in learning. We analyzed several augmented reality applications and chose Blippar. It should be noted that there is a free version that cannot be used for commercial purposes, and project created with it can only be viewed using a test code and will be watermarked, but it included access to all features within Blippbuilde. The application allows users to create an augmented reality both for viewing in a mobile application and in a browser. The first option is more appropriate in the classroom. To start creating a project, Blip, teacher needs to select a marker. This marker can be an image or a word. Students use this particular image or text as a marker. The program recognizes it and displays augmented reality objects. If the marker is a word, the student can scan it with the phone camera in the text and even pointing the phone camera at the computer screen and see the result. It is possible to upload 3D models, various images, audio and video files, documentation of different formats, links to the sites and social networks when creating project in Blippar. When preparing for classes using our application, we combined several different objects and related to one concept in one project, Blip. Thus, we created an interactive study guide with our elements, as we called it. To work with such an interactive study guide with art elements in class, the teacher gives out a printed marker image to the students and tells the code that matches it. To start working, a Blippar application must be installed on students' mobile devices. During the first year of study, students majoring in chemistry start their acquaintance with the chemical laboratory in the classes of laboratory chemical practice. It is during this practice that students first become familiar with chemical glassware and equipment, their purpose and the methods of handling them. Therefore, it is a very important component of the practical training of a chemist and future chemistry teacher. During classes, We offer students a marker image that needs to be scanned using the Blippar application and the corresponding code to familiarize themselves with the new type of equipment, the operation with chemical glassware, the methods of work. After acquaintance with the description of the equipment and methods of working with it, the students can proceed directly to the implementation of the laboratory work. According to the educational programs at our university, second-year students of the specialties chemistry and biology and chemistry start studying organic chemistry. The teaching organic chemistry experience at our department shows that the study of organic chemistry causes difficulties for the students, primarily due to the large number of organic compounds and the peculiarities of their spatial structure. Often, to understand, of course, and the mechanisms of a reaction, you must first understand how a molecule is made. Using augmented reality helps to meet this challenge. To create augmented reality objects while studying the topic carbohydrates, we use the Blippar application. For example, to study the material on the spatial structure and stability of conformations for glucose, the marker glucose was created in the Blippbuilde application and the corresponding code was assigned. First, students see a schematic representation of the cyclic structure formation. They can also, by clicking on the corresponding image, go to the 3D model that allows the molecule to be viewed from different points. Then, students can go to the animation that illustrates the cyclic structure formation. At this stage, if necessary, it is possible to return to the previous scene, the scheme and the three-dimensional model. Or they can go to the next one to see the transformation of one conformation into another. So the application allows students to freely move from one scene to another if they need to look through the information again. At the end of the classes that were held using our study guides, we interviewed the students to find out what they thought about using augmented reality while studying organic chemistry and laboratory chemical practice. 75% of the students surveyed believed that Blippar facilitated the perception and understanding of educational material and was an effective addition to real-life learning. 92% of students noted that using Blippar saved time needed to learn material because they did not need to search for information from different sources. Everything that was necessary for the study was tied to one image marker. 92% of those surveyed said that the app was convenient and user-friendly. It should be noted that 8% of students had difficulties installing and using the application, and 67% of students cited the need to install the application on their gadget as a disadvantage of the Blippar application. Interviewing and observing students while using Blippar, as well as our work experience with this application, lead to the following conclusions. The undoubted advantages of Blippar are: it is a free application if used for educational, not for commercial purposes. Doesn't require much space to install. The interface is simple and user-friendly. Any image or text can be used as a marker. One marker, several elements of augmented reality. The application allows to upload different types of information. After scanning the marker, students should not hold the screen on their mobile device only in one position relative to the marker. Using the interactive study guide with our elements created in the Blippar for classes in a real-life chemical laboratory is safe and does not require expensive glassware. With all the obvious advantages, working with Blippar has its drawbacks. To work with Blippar, students need to install it on their device. Students need to enter special code to work with the marker image. Each marker has its own code. 3D models of chemical laboratory equipment and molecules of substances are very few and they are not for free. We believe that these disadvantages are insignificant compared to all the advantages of the Blippar application in creating augmented reality objects which it provides for education, including the study of chemistry. Thank you for your attention.